kiddos. Section 2.4, how was it? Okay, so maybe a couple questions, but not too bad. I mean, I would love for us just to work on the review all of class. I was getting something important back here, but I don't remember what it was. Oh, here we go. No, that's not it. Okay. What are you guys talking about? You know what's really sad? I forgot until today when I went to go be like, ugh, I should start making this. Because last year, CalcAB had their answers all nice like this. I forgot I had Lowell make me answer keys for BC. So all year we've been doing the annoying scrolling thing when it was all right here waiting for us. That's okay, I found it. Number 6. Not that any of you cared about that explanation, but here we go. A, -2/pi. Do you see the negative sign? It was secant lines, right? Nice. So -2/pi, and then B is 0. Huh? Anybody else? Okay, -2/pi and then 0. Number 10. A is -2. Could you have realized it was a derivative and then maybe solved with the shortcut rule? Yeah. Let me check the directions. Number 10, the slope. It just says the slope of the curve. You could have done a derivative. I wouldn't have judged. So then -2 was the slope. Letter B is the tangent line, which you guys could have left as y plus 3 equals -2 x minus 1. Totally fine. But if you did simplify, make sure you didn't simplify it incorrectly. That would be sad. And then letter C, an equation of the normal. What? Ha! Oh, sad day. Nope, that's not what I want. This is what I want. Remember how there was like mathy stuff Friday? And I was like, oh, hey, including like these explanation-y things of this word named normal or called normal. Some of you might have actually been like, I think Miss D said that was actually in the book. So if I just turn the page until there's like, I don't know, explanation-y things. Oh, like this guy named Fermat. Or there was another part. Oh, it's not as obvious though, is it? About the word normal. Oh no, the book is actually supposed to teach us things. Teach us unless we read it. Oh, I have a lesson in that. It's called being in the Word. Anyway, coming back. You can sit there all day, but it's not going to help you unless you open it and read it. Some of you are like, meh. No. Okay, so what's going on? History of mathy stuff. Pierre de Fermat. Here, Jake. How do you say his name? Oh, there you go. That guy was a lawyer who worked for the regional government in Toulouse, France. I think that's kind of how you say it. He invented his method of tangents. Tangents in 1629 to solve the problem of finding the cone of greatest volume. You guys realize these things that we just say, oh yeah, that's calculus stuff, they actually were discovered to solve a problem. That can be formed by cutting a sector out of a circle and then folding the circle to cut the edges, to join the cut edges. And a lot of these things were based in geometry, ironically, because we say geometry is like meh, easy, like middle school, 10th grade, 9th grade math. A lot of the geometric problems are where some of these higher concepts in abstract math. Anyway, James Calvin said it better. This guy came up with tangents, okay? But the word normal, when analytic geometry was developed in the 17th century, European scientists still wrote about their work and ideas in Latin, the one language that all educated Europeans could read and understand. The Latin word normalis, which scholars use for perpendicular, became normal when they discussed geometry in English. So does it have anything to do with the English word normal? No, it has to do with Latin, because that's what perpendicular was in Latin. Anyway, interesting. The normal line to a curve is the perpendicular. You guys are cute. All right, look at your books. But I understand, right? Like normal, what is that? So coming back, to our homework. If you didn't read your book. Opposite reciprocal. Opposite reciprocal slope. So 1/2, and you could have plugged in y plus 3 equals 1/2 x minus 1, or simplified 1/2 x minus 7/2, which I think was someone's summer review quiz question. Was that you guys? You guys wouldn't have simplified, though. Anyway, I think it was an AB one. And then if you guys graph this one and graph the tangent line, you should have seen, yay, 90 degrees, as long as you had zoom square on to make it all nice and even. Zoom, zoom, zoom. All right, are we good? Number 30. Could you have solved with the definition? Oh, gross. You would have had to cube that guy? That would have been fun. There's a trick for perfect cubes. But anyway, you could have taken a derivative, and you could have gotten 4/3 pi. Well, that wouldn't have made sense. Oh, I was going to say 4/3, but you could. I would have just brought down the 3 and said 4 pi r squared, right? Anyway, 16 pi. Inches cubed per inch. Was that a little bit weird? Inches cubed per inch. Yes. Why is that important? Could you have simplified to be inches squared? Why not? No, it's a good idea. Inches cubed over inches can just reduce to be inches squared, but why not in this example? It's cubic inches of volume per inch of radius. That would be what number is this? Oh, it says with respect to the radius and not with respect to time. You were thinking dt when it was dr. So dv dr would just be like an f prime of x, dy dx. Does that make sense? Now, if it was with respect to time, like a balloon, that would be different. Yeah. Next one, number 42. False. Why? The slope is undefined. Is that easy to see? Yes, if you think about the pointiness, right? Absolute value of x, basic graph. Is there any slope at a sharp point? No, because the slopes are all -1 here, +1 here. They do not agree at the cusp? No, at the vertex. At 0. Number 44, you guys are at E. Sorry. Oh, nope, just kidding. Number 50. It's number over 0, isn't it? Because the slope is infinite. It's saying investigate whether the curve has a vertical tangent. And it was technically asking you to use math to do it, not the graph itself. How do you know if there's a vertical tangent? Wait a minute. Tangents, slopes, derivatives. So what's the derivative of number 50? X to the... And as soon as you have x to the -2/5, isn't there a denominator that could sometimes be undefined? Here, I'll just deal the whole thing. So wouldn't the f prime of 0 be number over 0, which would be to infinity and beyond? And doesn't infinity and beyond mean a vertical asymptote? A vertical asymptote of a derivative, or wouldn't an infinite slope point to a vertical tangent line? Because vertical lines always have what kinds of slopes? 0 is horizontal lines. Higher, 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 to infinity and beyond. Vertical lines have infinite slope. Vertical lines have infinite slope. So our infinite derivative is actually perfect because it shows the infinite slope of a vertical line. Yeah. Because it depends on the graph. Like, for instance, look at, what are the two no's, 49 and 52? Did you guys read the entire description from up above? The curve has a vertical tangent if, as you go to 0, the derivative is negative infinity or positive infinity. Now, hold on. Did you guys keep reading? In each case, the right and left-hand limits are required to be the same, both positive or both negative. Ooh, what does that mean? The one-sided limits towards the point that we're talking about must be in agreement. If you look at this one, we didn't actually check the sign. I should have gone one step further. If we were to check the sign, we would have had to come from below, and we would have had to come from above. Of, who is it, f of x? And as you come from below or above, if you plug in a negative, won't it be squared to be a positive? And if you plug in a positive, won't it be squared to stay a positive? So what's true about the signs from either direction of your derivative as we come in? Sorry, we should be taking it of f prime, my bad. They're both positive infinity. So they're in agreement, so yes, vertical tangent line. But if you look at number 49, it's going to be x to the negative 3/5, which can sometimes, with the odd power, stay negative and sometimes flip to positive. They're in disagreement, so therefore 49 does not have a vertical tangent. And then in 52, same thing. If you subtract 1, it's 2/3 x to the negative 1/3, which can sometimes be positive and sometimes be negative. So that's the key. The limits need to agree. Kathy? Yeah, good luck. Hopefully she's there. All right. Pause. Vertical tangent, just to make sure from the very beginning, vertical tangent is describing the graph of an original function. Vertical asymptote would be what's going on to the derivative function. So you still have a vertical asymptote of an original? Yeah. Who has a vertical asymptote? Not of the original function, because it's 2/3. If it was negative, if you had a denominator, but you don't have a denominator. And number 52, you just have remember, this is just the cubed root of x squared. This won't be undefined anywhere, because number 1 is cubed root, so I don't even care about negatives. And number 2, function has vertical asymptote. His derivative, on the other hand, his derivative is 0. So his derivative does not exist at 0, but his original function, the domain, is all real numbers. Or we have a derivative that doesn't exist going on. And so for this guy, you would have taken a limit as h approaches 0 from below the derivative. And as from below, you would get out negatives, so that'd be negative infinity. As you come from above, positives would pop out of positive, positive infinity. So what's going on with this guy is they're in disagreement. This will be a sharp point. And the sharp point would probably look something like that. Because the slopes are going to negative infinity from one direction. The slopes are going to positive infinity from the other direction. And they're in disagreement at the sharp point, which is why the derivative does not exist. Which is very different than the one that we were just doing here. I don't like that graph. It's trying to show you the graph. This is where it gets confusing. This one is showing you the graph of This is the derivative. This isn't f, this is the derivative. So this one, give me one sec. This function would look something like this. This would be f of x, to where positive infinity from one direction, positive infinity for the other direction. That's a true vertical tangent line. But that's the graph of the derivative with the vertical asymptote where they're in agreement. Maggie? Because in this derivative, wouldn't this one be number over 0? Oh, it's a vertical tangent line. No, it's not. It's a cut. So we have to check, because if they're in agreement, it's really a sharp point. If they're in agreement, then it's really a vertical tangent line. Does that make sense? A limit is a way of analyzing exactly why the derivative doesn't exist. The number over 0, the infinite slope, isn't enough to say whether it's a vertical tangent line or whether it's a point. A sharp point with curvature before and after it. This sharp point is just like, oh, -1, +1. They don't agree. That's absolute value of x. But that sharp point, it's infinite slope, not agreeing and still coming to a point. Kind of makes sense? Because does f of 0 exist in that one? Yeah, there's a point. Does f of 0 exist in this one? Yeah, so the hard part is only with the limits to infinity and beyond seeing the agreement will we know the difference between that and that. Okay. Coming over to put it down just for that. What was it, period 2? Period 1. I was like, I'm putting that down. I haven't like full on written, I've been close. The nice thing is, this, you have to take the top off. Those you don't. So that usually catches me. But sometimes I do write on it with the top and I'm like, ugh. Huh? Yes. Thank you, that's where I was going. That's the last even, right? Not Windows Media Player. Okay. So with this guy, f of 0 exists, no problem. Take the derivative, all of a sudden negative exponent. Oh no, the derivative doesn't exist, but how? Test both sides. They're showing you the derivative. They're saying, hey, the one-sided limits, from one side, the derivative is going to positive infinity. From the other side, negative infinity. It's going to be a cuspy thing like that. No. I know, right? This is the derivative. Up there, yeah. Yeah. And specifically, oh yeah, negative infinity, positive infinity. Positive slope, negative slope. It's like that. Oh dear. Okay. That's just not fixing itself in any way, shape, or form. All right, kiddos. Do you have any questions on the odds or on the evens that we already went over? About sensitivity, about taking derivatives. I mean, could you do it the limit way? Yes. I mean, that's chapter 2. It's technically limits, but can you be using your basic derivative rules? Yes. Sally, do you feel confident enough on derivative rules that you can shortcut it? Cool. Eric, you too? Okay. Questions on homework? Yeah. Yeah. Sensitivity. A patient's temperature T as a function of the dosage D of a medicine is given by, got it. Find and interpret the sensitivity of the patient's temperature to the dosage when D equals 2 milligrams. The idea is on these that you don't want to, I hit something else. Okay. You don't want to overdose the patient. Well, I mean, they might want you to, but you're not really supposed to. There we go. So then T of D, you guys have it, right? What is it? And you're trying to find the sensitivity when the dosage is 2? So how quickly are you going to expect them to respond to it when the dosage is 2 milligrams? Like say you need to get them within a safe range and it needs to happen fast, like this is something that you would consider. So just take the derivative, T prime of D, and that's from what we talked about with sensitivity. You're just trying to find the delta T over delta D, which is why we're doing the derivative itself. They, as in like nurses at a nurse's station? No, not specifically. But the prescription companies in the advice that they give to hospital staff, it would be involved in the rationale. But you would need to talk to actual nurses on nurses on duty will be the actual nurses. Like you could ask them as to how they figure out what the dosage is in like critical situations. Because like in normal situations, it doesn't make a big difference. But they do consider a lot more than just like, oh, let me read the bottle and do what it says. Every adult, no matter what size, needs to. You know what I mean? Like, yeah. Aryan, does that make sense? Then just plug in 2.
Can I just have one general question?
Yeah.
So it's asking, determine whether the graph is tangent. So there's a sharp point and there's an exponent.
What number?
Number 15.
Oh, so if it doesn't have a tangent. As to when it wouldn't exist. That would be it unless there was a discontinuity. I mean, but then you would see it in the domain in some way, shape, or form. Yeah. I mean, piecewise functions, be careful because it might look like there should be a derivative where if there is a discontinuity in the beginning, there isn't. Like that would be the one warning. Like the exception to like the derivative looks like mathematically it would exist when if there wasn't even a point to begin with, there can't be a slope at a non-existent point. But yeah, no. Your DNE as far as like an existing original point are only going to be sharp point or a vertical tangent. Good. Okay, are we done? All right, let's review. I don't mind. Can we talk about the review really quickly? A second ago in your classroom so that you guys could read it and see it. What the review assignment is. I think I actually have it right down here. Do I? I do. Hey, and I have the evens too. And hey, it might be nice for you guys to see the evens on the review, right? So maybe I should like post pictures of it or something. Anyway, I want you guys to peek really quickly at the assignment itself. Dilemma. You guys don't bring books ever, do you? Well, this is going to be a party. Of my book with the answers in it because I don't have any spare books because I don't know why. James Calvin. Okay. James, I want you to look at the ones at the end, like the 47, 49. Guys, what normally happens at the end, I'm pulling up my PDF thingamabobber tiny scanner. Yeah, there he is. What normally happens at the end of an assignment? Doesn't it usually get harder, like just in general of homeworks? Okay, so let's see really quickly. Oh, do I already have your pictures taken? I'm checking. What? What a champ. Okay, this is the beginning of your review. Go team. I'm going to take a picture at the very end to prove a point. But did I give you any problems from the end? Actually, I'm not sure if I did. Let me freeze the screen really quickly so that you guys can see them. Remember, you don't technically need to write the problems. I'm not going to like steal this from you and take it away or anything crazy like that. I need to go peek at the assignment really fast. Oh, I didn't even give you any ones from the end. That's why it's not there. Okay. Sorry, pause. I'm having you guys start working. I'm going to give James back his book. Usually, at this anything but the limits chapter. Actually, at the very end of the review is this orange box. Definitely stumps you and slows you down a lot. And so in future chapters, we might actually do reviews backwards. That way you guys are working on the harder problems first, and then you get to end with the easier ones. We kind of figured that out a couple years ago with Gerardo, that it was easier just to start here. It was easier to start at the harder problems, and then like you guys are less likely to get stuck on the easier ones on your own. But the nice thing is, for your guys' review, I had you stop somewhere over here, which means you never get to the orange box. But if you want to be challenged, what should you probably look at tonight before tomorrow? Okay, sounds good. Thanks, James. There you go. By the ways, 1 through 20. Oh, start playing with those limits, and maybe we'll check whatever answers or whatever problems you guys have done by the end of class. would have gotten 2 minus. Do you kill a seal? You sure? Okay. Not distributing the negative?
Oh, wait, you know they did? I canceled out the 2 plus x by the denominator. You see that?
I killed a kitten. Because I see it way too often. Because whenever on the summer review quiz, I was like, kill the kitten. Because there was that complex fraction on the summer review quiz in AB, and BC. So many kittens there. Seals die when you don't distribute this negative. Then that reduced. And you end up with negative 1 over 2 times 2 plus 0, which is negative 1. That makes sense? Seal. I didn't show it very nicely, but it's down here. 2 minus okay? Has a decent. You just have to think about with the winning. I always think about it with dividing. If you're dividing by bigger and bigger and bigger numbers, your number is getting smaller and smaller. The denominator wins. So the denominator wins 0. Yeah. Like pizza and hundreds, pizza and thousands, like I think of denominators as like cutting a pizza. So cutting it into tens, hundreds, thousands. What's happening to your piece? So when the bottom wins, 0. Top wins, infinity and beyond. Check it out.
I just think of it like number over 0. So is it number over 0, number over 0. So like the
Bottom 0, top. Oh, that's an interesting way of thinking about it. P.S. I'm announcing to all my calculus classes that the Share the Hope wall is officially up and running. In that there are cards back there ready for you guys to take if you have a submission. That's on there. Please don't do a meme. Just, I don't know, unless it's one that's actually encouraging. But memes are mostly entertaining, and entertainment only lasts. Entertainment's temporary. I'll put it that way. Hope is much deeper than that. But it could be, it doesn't have to be a verse. It could be something a teacher says. It could be a quote from a book. Huh?
You know the one where about the girl who had all the symbols like floating around? Remember the meme? What it? Because I think there's like a unit circle in there, so I'm like, if she can do trig, so can you.
That's cute. That's cute. Dun, dun, dun. But anyway, if you guys look back at the basket on my desk, there's Share the Hope submissions. So if you have one, don't do it in pencil. Do it in some sort of like pen or Sharpie or something or others, and then put it in the submission box. And I will consider. But yeah, you guys can think anything that could be encouraging. What I meant was I didn't really want ones that are just like kind of like hate your life. I don't know. There are all these ones from last year, the last 2 years. That was all. Yeah. I'm like, it's funny, but it doesn't really help anyone. Feel free to reach out in your groups. I have the evens that we could check. I could dual page it and show more problems. A few people look kind of bored. You guys see why I had it 1 through 20 off?
I know. Thank you. I was like, why does this seem too easy for me?
Yeah. 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 Well, you can't possibly take a limit to both at the same time. So you'd have to split it up and do it one at a time. I think that's the point. So it's trying to make you think about horizontal asymptotes where you have to consider both. So to the right, it would be positive infinity. To the left, it would be negative infinity. There is no, you could say there's no agreement. It doesn't agree. I wouldn't say D&E doesn't exist because the one-sided limits to infinity aren't meant to agree.
So on a multiple choice question, would you answer
Multiple choice question would never show plus or minus infinity. What they're trying to have you think of is horizontal asymptotes checks both. Or limits to infinity, you can't just assume that it means both. Yeah. Yeah, that's what I would do. But if you want to put does not agree, that's fine too. But don't say D&E. For 6 and 7, you can box both answers. If it does agree, just box one, but if it doesn't agree, show that they're separate. That's funny. No, it's not really used. The problem is if we did come up with one that we couldn't use it on the AP in a way they'd understand. That's the bummer of it all. Because you're not just doing it for me, you're doing it for them. Alright, kiddos, if you want, I'm going to go ahead and just post the answer key to the evens in Classroom. You can also check out the end of the video today, and it's totally just, hey, look, pause. Well, I probably should have gone a little slower. That's kind of mean. But you could pause the end of the video today, too, and then check the evens before tomorrow. Tomorrow, calculator? No way, Jose. Alright, cool, kids. Be ready. I'll see you later. I think that's the end. Oh, nope, there's one more. No. That was chapter 1, chapter 11.
Oh, we're chapter